So now here we have, so in this question we have, this is a straightforward application of what we have learnt. So here we have three random variables, which are the points earned in a 2 free throw attempts, points earned in 1 field goal attempt, and points earned in a 3-point shot attempt. So if the x1 is the points earned in a 2 free throw attempt, x2 is the points earned in a field goal attempt, and x3 is the points earned in a 3-point shot. So what is the distribution of the random variable x2? The points earned in a field goal attempt. In a field goal, how many points can you make? Either 0 point or 2 points. So x2 takes the value 0 or 2. What is the probability of 2? It is 711 by 1597. What is the probability of 0? It is 1 minus 711 by 1597. What about x3? x3 takes the values 0 or 3. And what is the probability of 3? 128 by 385. What is the probability of 0? 1 minus 128 by 385. What about x1? It is the 2 free throw attempt. So it can be either 0 or 1 or 2. What is probability of 2? It is success on both the trials. It is like success, which is what? 476 by 555 whole square. What about 0? 1 minus 476 by 555 whole square, because this was failure. And what about 1? It is either success failure or failure success. So it is 2 times 1 minus 476 by 555 times 476 by 555. So you have 3 random variables, x1, x2, x3, and you have their corresponding distributions. Now what do I have to do? I have to find which one has the highest expectation. So what should I do? Find the expected value of x1, find the expected value of x2, find the expected value of x3 from the distribution which I have set up, and I find the expected values are the following. And what can I say? So what can I say? I find that the highest expectation is for the random variable x1. So the 2 free throw attempt has the highest expected value for rows. That's what I have. Next, what do I have? I have the which one has the larger variation in outcome, a 2-point basket attempt or a 3-point basket attempt. So I have to find the variance of those two. So variance of x2 is what? Expected value of x2 squared minus expected value of x2 whole square. What is expected value of x2 square? It shall be 2 square times this. We do not include the 0 there because 0 is 0, minus expected value of x2 whole square, which is 0.89 square. What about variance of x3, which is expected value of x3 square minus expected value of x3 whole square. So what is expected value of x3 square? It is 3 square times 128 by 385, because x3 took the values only 0 or 3. So we don't have to include 0, just the 3 is enough, minus expected value of x3 square. Now we compute the two numbers and we look to see which one has a larger variation in outcome. What about the variance of, what about the next question? If the team is losing by 1 point near the end of the game, which of the following offers a bigger chance of winning? Rose's attempt a field goal or Rose's attempt to 2-3 free throws? Are the assumptions necessary for a comparison? So here we have the two events C1 and C2, which is succeeds a field goal. C2 is succeeds a 2 free throw. Probability of succeeds a field goal is 711 by 1597, and succeeds 2 free throws is 476 by 555 square. So the corresponding probabilities are 0.4452 and 0.73558. And then we compare the two probabilities to get the answer. So which one would be a better option? The 2 free throw attempts would be a better option because the chances are higher here. So that was 51. Yeah. Let's look at 38. So here, imagine the investor invests 10,000 for 1 month in a company whose stocks either go up by 80% after a month with probability 0.5 or drop 60% with probability 0.5. After 1 month, the investor sells his stocks and use the proceeds to buy stocks in a second company. So what's happening here is we are investing 10,000 and we are continuing with that money. We are investing it first, and based on what we have, we are investing it for the second time. So now the question is, what is the distribution of the final outcome and what is the probability? So we started with $10,000, and then what do? We start with $10,000 and it either goes up by 80%. If it goes up by 80%, then this is what happens. And if it drops by 60%, then this is what we have. And with the corresponding probabilities 1/2, 1/2. Now, so if I call this success, I have success failure, then I have success failure, then I have success failure. So I can have either success when it goes up both times, or success failure goes up once, falls later, or failure success, first falls, then rises, and then failure, which is drops both the time. So now, based on this, my outcomes, my final values are 32,400, 7,200, 7,200, or 1,600. So probability of 1,600 is when it drops both the times, which is 1/2 times 1/2. Probability of 32,400 is when it rises both the times, so 1/2 times 1/2, and 7,200 happens when we have success failure or failure success, which is 1/2 times 1/2 plus 1/2 times 1/2, which is 1/2. So the expected value of y is the numbers times the corresponding probability, which is the observed value times the corresponding probability, which is 1600 times 1/4, 7200 times 1/2, 32,400 times 1/4, which gives me the final answer, which is the mean of y. Next, a law firm takes on contingent fee takes cases on a contingent fee basis. If the case goes to a trial, the firm expects a rise, expects $2,500 as a part of the settlement if it wins, and nothing if it does not. The firm wins 1/3 of the cases that go to the trial. If the cases do not go to the trial, the firm wins nothing. Half of the cases do not go to the trial. Be sure to add the appropriate units. Define a random variable, find the expected value, find the standard deviation. Very straightforward. The important thing here in this question is this line. The firm wins 1/3 of the cases that go to the trial. That means if it goes to the trial, then it wins 1/3 of the cases. So that is a conditional probability. So if you can figure this out, this problem is done. So my random variable here is the earnings, and it takes the values nothing, which is 0, or 2,500. How do we assign the probabilities? Well, let A denote the event that the case goes to trial, B denote the event that the case wins the trial. So probability of not going to the trial is 1/2. Probability of going to the trial is 1/2. Probability of winning if it goes to the trial is 1/3. Probability of losing if it goes to the trial is 2/3. Now, why is the probability of winning, given that it goes to the trial, 1/3? Because it says clearly that the firm wins 1/3 of the cases that goes to the trial. So so here is the following tree. So we have probability of 2500, which is winning, which is one half times one third, which is 1/6, and for 0 it is 1 minus 1/6, which is 5/6. You can think of this as 1 minus 1/6, or the sum of the other two probabilities, which is 1 half times 2/3 for going to the trial and losing, or not going to the trial at all. So that's what we have this. Now we have to find the expected value, which is pretty straightforward. You know how to find the expected value. And then we find the variance. Then we find the standard deviation. We first find the variance and take the square root of the variance, and that gives us the final answer. Question 42. The maintenance staff at a large office regularly supplies fluorescent ceiling lights that have gone out. So here is the distribution of the random variable, which is the number of lights that needs to be replaced. So what is, once again, this is exactly same as the reams of paper, which was question number 41. What is the expected number of lights to be replaced? Expected number of lights to be replaced, which is expected value of y, which is 2.25. What is the standard deviation of the random variable y, which is, it is the square root of the variance, and this is how we calculate the variance. We find the expected value of y square, which is 6.05. Find the mean, which is 2.25. Subtract 2.25 square from 6.25, which gives me this number. Take the standard deviation, which is the square root of variance, which is 1.36. And then how many should it expect to have left after replacing those that are out? So we start off with 6 lights, and then we replace, and then we have a few left. So the number that are left is 6 minus those replaced. So my random variable is 6 minus y. We have to find the expected value of this. So here once again we use expected value of ax plus b is a times expected value of x plus b, and here my a is, for part C, my a is -1, here my a is -1, and my b is 6. So we get 6 minus expected value of y, which is 3.95. Then we talk about the standard deviation, which is the square root of variance, which is the variance of 6 minus y. Now once again, variance of ax plus b is a square variance of x. So my a is -1, my b is 6. So we have the variance of 6 minus y is same as, so maybe here you can put in, this is same as square root of variance of y, or because we had -1 square, which was 1, which gives me standard deviation of y. So standard deviation of w is same as standard deviation of y, which is 1.36. After which we have the time taken, when we know it takes 10 minutes to replace each light. If that happens, then the time taken is 10 times y. So expected value of y is expected value of 10 times y, which is 10 times expected value of y, which is 10 times 2.05, which was the mean which we had found in part A of this question, which is 20.05. So standard deviation of t is square root of the variance of t, which is square root of variance of 10y, which is 10 square variance of y, which is 10 square standard deviation of y, which is 10 times 1.36, which is 13.6. Now the next question. So in the next question we have, hang on, okay, so next question. So read the question here. So I'll give you a few seconds to read the question. And what do we have to do here? In this question, we have to find expected value. So the first thing is, what is the random variable here? The random variable here is the exchange rate from pesos to dollars. So the random variable takes two values, 12 or 24, which is 12 pesos per dollar or 24 pesos per dollar, with probabilities 0.9 and 0.1. So what we are doing is the following. We are taking 1,000 US dollars, right? And we could either invest them in a bank in US, which gives me 10% amount, or take that $1,000, convert it to a Mexican currency, and deposit that in a Mexican account, which gives me 16% interest, and reconvert that back to US dollars. So the question is, which of the two strategies will be better? So the first choice is deposit 1,000 in a US bank that pays 8% amount. So if we followed that strategy, my amount would be 1,080. Or I could take that 1,000, or I could take that US dollars, convert that into a Mexican currency, so Mexican pesos, invest that for 16%, get my pesos, then convert that to dollars, then again convert that to dollars. So here I have one exchange rate, and here I have another exchange rate. Exchange rate at the beginning of the year, exchange rate at the end of the year. Now the question is, will this strategy, the second one, yield me a better result than the first one, which is investing in the US account? So let us see. So we saw adopting the first strategy gives us $1,080. What happens if we follow the second strategy? So if we follow the second strategy, what happens is as follows. We first convert my 1,000 US dollars to Mexican currency at the current rate, which is 12 pesos per dollars, which gives me 12,000 pesos. Now I convert that 12,000 pesos to the now I invest this 12,000 pesos in a Mexican bank at 16% interest rates. So I get 12,000 times 1.16. Now I convert this amount to US dollars again, and that is 12,000 times 1.16 divided by the exchange rate. So this is my final answer, and this involves the random variable z. So what is the expected value of this? This is this constant, which is 12,000 times 1.16 times the expected value of 1 over r, which is 12,000 times 1.16 times the expected value of 1 over r. What is the expected value of 1 over r? It is 1. So the observed values of this random variable were 12 and 24. So we have 1 over 12. We have 1 over 12 times the corresponding probability plus 1 over 24 times the corresponding probability, which gives me the final answer. So the choice 2 has a higher expected value in 1 year. Now let's look at the next question. Suppose I do the following, the reverse. I have a Mexican 12,000 pesos and I want to convert that to US dollars. So what I do is I could either invest that 12,000 in a Mexican bank and earn a 16% interest, or I could convert that to dollars and invest that in a US account, get that 8% and reconvert that to Mexican currency. So now once again we have two choices. Let's say choice 2, which is invest the 12,000 at 16% at a local bank. If I followed this, I would get 12,000 times 1.16, which is 13,920. And then if I followed the first strategy, which is I took the pesos, converted that to dollars, earned the 8%, then converted this dollar amount back to peso, the question is, what would I get then? If this is the strategy which I adopted. So what I do is I take the 12,000, convert that to US dollars at the current rate, which was $12, which gives me $1,000. Then I earn that 8%. So I multiply by 1.08 and then I convert it back to peso. And this time I multiply by r instead of dividing r because I'm converting from dollar to peso. So that gives me 1080 times R. So the expected value of W is 1080 times expected value of R, which is equal to this, and that gives me my final answer. And we find this choice has a better expectation than the previous choice. So now the next question is as follows. An office machine costs 10,000 to replace under a mysterious hard to find problem can be found and fixed. Unless a mysterious hard to problem can be found and fixed. So we call technicians and they each charge us $500. The chances that they can fix is 25%. Calculate the probability model for the number of visits needed to fix the machine. So here the number of visits needed, that's the random variable. So my random variable can take 4 values, the either 1, 2, 3, 4, because we allow only 4 visits. So the random variable takes value 1 when the first person fixes it, which is 0.25. The random variable takes the value 2 if the first person fails and the second person fixes it. Now if we assume these two events are independent, the probability of the first person failing is 0.75, second person fixing it is 0.25. X equal to 3 is the first person fails, the second person fails, but the third person fixes it. So probability of the first two people failing is 0.75 square and the third person fixing it is 0.25. X equal to 4 is the first 3 people failed. So we don't care what the last person did. As long as the first 3 people failed, we would be calling 4 people, and that is equal to 0.75 to the power of 3. That gives me my distribution. Now I want you to see the similarity between this problem and the problem on the insurance policy, where we spoke about the number of clients visited. So here, when we spoke about the number of clients visited, which was 3, that was 9.9 times 0.9, 0.9 times 0.9, which is 0.81. We did not care about what happened. We did not care whether the third client actually bought or not. As long as the first 2 clients do not buy, we visit the third client. So we did not have to put in anything for the third client. So similarly, for this problem here, we don't care if the fourth mechanic can fix the office machine. As long as the first 3 cannot fix it, we will need the fourth person. So it is 0.75 to the power of 3, and that gives me my expected value. Then we look at the next random variable, which is the expected amount spent on this machine. So the amount spent on this machine is either 500 if 1 person visits, 1000 if 2 person visits, 1500 if 3 people visit, 2000 if 4 people visit and fail. So 2000 is if 4 people visit and fail. So let me say that again. 500 is if the first person visits and fixed. 1000 is if the second person visits and fixed. 1500 is if the third person visits and fix. 2000 is if the fourth person visits and fixes it. 1200 is if the fourth person visits and fails, because if the fourth person visits and fails, we have to give money to the fourth person, which is 2000, and we have to buy a new machine, which is 1000, which gives me 12,000. So probability of W would be, so the distribution of the random variable W would be as follows, and the expected value would be this, which gives me my final answer.